Okay, so seems we're live. Hello everyone, and welcome to another day where we do a game engine and Flappy Bird in Golang from scratch, right? So this is a continuation, perhaps the last or second to last Flappy Bird episode before we go probably back to nMage or we do some other project, maybe a bigger game. So let's run this, see where we got to since last time. So we got collisions to work. We have the pipes coming in properly, and if I collide anywhere like this one, we get you lost, right? We cannot restart yet. If we fall under the screen or we go up, we don't lose yet. So we have these things, and we don't have a score. So we'll do these things now. Now, before we get into that, we had some mystery last time where we had to set the box colliders to a unit of 2, and we weren't sure why that was the case. That was very confusing. It turns out it's a very stupid reason, is that simply put, the model exported from the Blender was the size 2. That's it. That's really all it was. So if we look at models, I already prepared one. We are loading for all our sprites. So if we have like a new quad, we can see for us sprites right now is just a cube, or sorry, a quad, facing the camera, and then on the quad we put the texture, and that's our sprite. But turns out our quad object has a size 2. So this guy is a size 2, and I made another quad that's size 1, and you can already see, and let me zoom in for you guys. Here, these are our vertices. This is the old cube that we were using, and this is the new one. You can see this is half. So the distance between minus half and half is 1. So between the bottom and the top of the quad is 1. It's just like 1 meter, for example. In here, it's between -1 and 1, so it's a distance of 2. That's why we had to do it. So now, all we have to do is here, I'm going to delete this quad, the big one, and I'll just replace it with this. This will be our new quad, which has a size of 1. And I think that's the only place we use it. Let's confirm. Yes, it is. And then wherever we do box collider 2D, we can just do a unit of 1. That should do it. And we should still get basically exact collisions, right? Let's run and see. So you be careful when you get your models out. Oof. So ish. That did not go well. Well, let's see. Are we using assuming in places something is like 2 or something? Like for example, the background. Well, everything is smaller now. Basically half the size. Yeah, so that's why. Because what happened right now is we essentially made everything half the size. So we're going to want to scale them up a little bit. So scale was 1010. And this worked before, because if you look at our orthographic camera, the width and the height is 20, not 10. Between -10 and 10, that's 20 units, and 20 units vertical and horizontally. We only set a size of 10 because our quad was 2, so we got 20. So in here, we will have to do 20. Same thing here. With this, at least the background should be good. There we go. Flappy is actually kind of nice, being small. Right. Let's look at all the scare reads and writes. All right. So yeah, if we just want everything like before, we want to multiply by 2. I'll make this 2. Z-axis we don't care about. What's this? Stop collider. Well, width is 2, height is 20, I think. Well, we'll do it and see as we go. We probably need a better way of setting these sides, so that's fine. For Flappy, it's okay. Okay. To here, to... All right, let's look. Perfect. Okay. Our bottom pipes need to be wider. There we go. To here. And we're back. Right, we're back to normal. There we go, perfect. Our colliders need to be adjusted as well. So collider is colliding. Do we need this half now? Bottom left is x position minus width into x position, I think it's the center for us, minus the scale into half. We have the scale because it was double the size, I assume. So let's remove all these multiplies and let's hope no, actually this looks correct. Where at the center we want to move half the x distance. Oh, let's look at this. Maybe we're not centered. Oof. Let's put the back. Let's draw our colliders. Luckily we have a way, and I hope these are accurate. Draw the first pipe, sure. Let's do that. And draw the bird collider. Let's do that as well. Okay. Drawing at least is good. Something else is not. It's colliding. Box collider 2D. So scale is this. Collider is being set to the same scale. I think that's fine. P dot carried right, so 220. Okay, scale. Position, read right. Well, so the drawing is wrong. Position read. So position minus. So you go from the center left. by half, and then multiply by scale as well. Yeah, and I think this scale multiplication is why it's going off. I believe so. No, scale is always 1. Scale. So we're scaling the sprite, but I think not the collider. The pipes are being scaled, at least. And the bird collider. What have we done? Scale. Bird scale. Bird sprites. Bird sprite scale. Yeah, it's being set to this. All right. So I want to check these values. Is colliding. So let's print a dot scale 3 dot string. Where collider scale is this. So we are getting 1.52. So yeah, that's the scale of the sprite itself. So we have 2 by half x. So this becomes 1 minus width. Yeah, it's fine. Scale, 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 scale. Plus, plus. So one thing is why are the colliders wrong, if at all? So bird collider and which model matrix? Bird box collider matrix. What if we use the bird sprite for a minute? Bird sprites should be the same. Where is the collider? Collider is something in there. Where is the collider? Where's the bird collider? Please tell me. There it is. What? I don't get it. So in our logic, Lost. Move the bird. And move the bird collider. Scales the same as the bird, and this is this. Same position, same scales, and everything. And I assume everyone is using the same quad as well. It should have been just a flip, no changes. This is just 1.5. So this is what we're seeing is 1.5 to 1. Could be the pipes that are wrong. Let's see. So when we create them, playing and starts. Top pipe and collider. So we have a new pipe. Just to check this guy. There we go. So the pipes have wrong colliders. This should be 1. And just to confirm, let's go and search everywhere. 1, 1, 1, 1, and 1. Okay, so this should do it, hopefully. Perfect. Nice. And there we go. Perfect. So the collisions are spot on. Nice. This is all done now. We can get rid of the print line here. Okay. So this is one change. Is just the scale of the model itself, right? So we don't need to have weird scaling for our colliders or anything. Now you just scale the base object and the collider scales with it. All right. Now what do we need to do? We need, and I think we can, let's keep the bird collider, draw pipe collider, draw, no, we don't need this. Okay. We need a score. We need a way to draw it. Sorry. So let's have our score, which is a uint maybe. And we do have a resources. If we look at texture, so each number is actually, so here 3, 5, and so on, 7. They are their own texture. This is better. We should use this. So we should actually display kind of like different sprites that make up the thing. But for now, we'll start with the most basic thing, which is just display a score somewhere. So maybe an update. Make a function draw score, because this will be a bit more complex later on. And here we just say draw score. And we can use some of these things. Is open. And here, so we want the size of the score. So score text is, we can use sprint the score, please. Score text. Let's add any. Okay. Okay. start positioning at 0, and the size is, so we want, let's get the window size. Size is full width, and height shouldn't matter. I mean, we can put it for height now. Okay. Score window. So let's begin the score window. Push our font. Set the cursor position in the center. So it's just going to be width divide by 2 minus x minus the size of the score. So we center it, hopefully. And it's the same. This will center it. So y is 0. Text is score text. Color is just white. Let's put it for white. Okay, let's see. We have score. Yep, there we go. Centered. Very nice. You lost. Okay. Now we need to detect. So how are we going to detect? Well, I think one way is we'll put a collider in the middle between each two pipes, and if you touch that, you don't lose, you get a score, right? But then we need a way of marking, like, oh, you know, we already got past that, we already touched it, so shouldn't keep increasing the score as long as we're touching it. Okay, so in Mr. Pipe, we're going to need, so this is the pipe collider, and we'll need middle collider, maybe middle collider. I think it's enough to put it on, for example, the top pipes. If it's top, what we will do is var middle call is this thing. So this by default will be null, right? But if it's top, then we will just set it 1 1. Right. You can put a comment. Is only defined for top pipes. There you go. Cool. So now we have something, and I think the distance, the opening between pipes is always set in stone for us. Where start? It's always the same, right? So our position is 10 plus some random spacing, blah blah blah, and this is minus 10 plus some random spacing. And we want it to fill the gap. Let's see. Going to be tiny, so very narrow collider down the middle that you can touch. Then we want to visualize it, hopefully. So where do we put it? Oh, we can center it exactly at the position of the pipe and just give it a huge height. That's the easiest instead of calculating anything. So we can say, well, pipe or P dot middle collider. We know this is the top pipe. Scale read writes dot set. So it's very tiny. So 0.1 on this. Why we want it to be really big? Just like 20. This should cover the whole screen. Let's make it a bit more, 30. And yeah, Z doesn't matter. and the position read writes equals p dot pipe position. There we go. Okay, and in our logic, so it's starting with this kind of huge size and it's following the pipe as it moves. And as we are playing and moving the pipe, so we move the pipes here. There we go. So we move the pipe, move the collider, and we want to move middle collider as well. Only if you know, if pipes I that is stop. Well, if it's even ones are, it's cleaner to put it here. Is stop bool and stop exist. There we go. Stop. If it is, then we move position read write is equal to pipe position. Okay, that's it. That should do it. Now check collisions. Where do we do this? Is colliding. Pipe logic. Pipe collisions. Pipe score collisions. So if you're not colliding with any pipe, then we'll allow you to score. You can just loop again and we can check this guy against the middle collider. And if so, we can go in the score. Oops. Where did we go wrong? Quads 44. 44. Position read. What? Did I forget to do something? All right, so we only do this for top pipes. Pipes I dot is top. If it's not top, or okay. So when we go to the center, ooh, nice, perfect. So we're getting something. Now we need to do what we discussed regarding what do you call it? We need to pause. So if you scored, you cannot score again before some time has elapsed, which is before you kind of before you pass and touch another one. I think the simplest way to do this is that we require you to touch a different collider. You cannot score twice in a row with the same collider. So the easiest way to do this I can think of is you have this. You have our score. Last touched middle collider, right? I guess. And this is going to be null. And when we score plus plus, if 5, so here assuming we touched it, we're colliding with it, if the middle collider is equal to this guy, then continue. Don't score twice in a row with the same collider, right? And then what we can do we score, and we update. So next time, in the next frame, we're still going to be touching this this collider, but this check will succeed and we continue, right? And there is no way that you will touch the same collider twice in a row. There we go, 1, 2, nice. We have scoring. Next time we'll add sounds, I hope. I've been working on a simple audio library, and we already have audio running in my test. Oops, it's actually a bit hard to play. We can load MP3s and so on. It's very nice. Trying to make it really easy and have all the basic functions one would like. Yeah. Okay. So maybe next time we can do sounds. But for today, let's wrap up the scoring system. Now, if we lost, we still want to draw the score. So after all of this, we can just say, well, you know, still draw the score. Dun, dun, dun. 1, 2, 3, 4. Let's say we lose here. 2, 7. Okay, score is still drawn. I think exactly in the middle. Can we center this? Sure. So the window takes a full size. Yeah, let's call this lost. Where we want to start drawing is in the middle, divide by 2 minus yeah, I shouldn't. Does it make a difference? Well, let's see. And yeah, color is fine. So we're going, and boom. Maybe. Thing is, for short sentences, there is a bug in calculate text size that doesn't give you accurate size. Not always. So this might be off. That's all. Well, it's okay. For now, this is fine. Now, the next thing is we actually don't do it with IMGUI. We display it as quads. So we display these nice, sweet textures. So we have this nice 4 and so on. So we break a number into all of this. So let's comment all of this out. And what we want to do is we have our score, and we want to get each digit out of it. So let's say while the score not 0. So if score is equal to 0, I guess that would be different handling, but otherwise, if score, while score is bigger than 0, so let's say we have a number like 1, 2, 3. We want to convert it into 3 different sprites. Sprite for number 1, sprite for number 2, and sprite for number 3. So we need to cut the number. And the way we do this is we can keep dividing by 10. For example, if we divide 1, 2, 3, divide by 10, that gives us 12.3. We take 0.3, so that's a 3. And then we're left with 12. And then we divide by 10 again, you know, or we take like the modulus, and that will give us 1.2. So that we draw the 2. And then we take 1, and that gives us 0.1, and so on. We have that. So for now, I just want to do this process essentially. So we want the digit to be, I think we can modulus like this, and then we actually divide the number. And for now, we can say digit is digit. Fine. Let's look just to make sure our math is right. Donate 1. Yeah, digit is 1. Oops. well, let's say we plus 5. So instead of score plus plus, score plus 5, just do this quicker. Digit is 5. Digit is 5. No, it should have been. Okay, say print line getting digits for score. And just so you know. Wait, what's this? Our score is 0. What do you mean? Score is 0, return. What do you mean? 5, okay. 15, we should have 15. What's the score not updating? Down. This doesn't make any sense. Score plus 5. What? This makes no sense. This may be debug. That this will break things. Okay, we'll say all score is score. New score. For now, let's just disable this. So print the score every time it increases, because it should be like, yeah, 0 and then till 10, then 15, and I mean, looks to be okay. Well, the score is this. So if the score is 5, we will get a digit of 5. And then we divide by 10, which would be 0, and then that's it. And then when the score is 10, we will get the first digit as 0. And then we divide by 10, we get 1. So the next digit is... oh, right. I'm dividing the actual score. Score copy. So of course it's not increasing. We need to operate on that. Yeah, let's give this. We don't want to change the score. Okay. Okay, 5 and 1, 20 is digits 0 and 2. Yeah, so we get the digits and we get them in reverse order. That's correct. We'll get if the score is like 55, we will get, or like 56, we will get 6 and then 5. So we need to display them right to left essentially, or we put them somewhere, sort them. But okay. So we have this, and we have a digit. And what we want to do, so we want to load all of them and then render score. We always want to draw scores, so this guy has to move into rendering, not in here, not in here. Okay, in renderer, I guess at the end, yeah, That's fine. Okay. So let's load all of the textures. So this guy is done. This guy is right there. So we want in init to load everything. Background sprites. So let's do load digits. Digit textures. Okay. So here, load digits textures. And it's essentially a bunch of this. So we have this digit textures, already quads. Digit 0 and digit 1, digit 2, digit 3, digit 4, digit 5, 6, 7, 8, 9. All right. I think even better is to just put them into one big array. So digits quads makes it easier to index. Digit quads, there we go. So digit quads equals make, and we have 10 of them. We have digits 0.png, and we just say, well, digit quads append digits. That's it. And we repeat this process 10 times. I mean, I guess you can put it in a for loop, but okay. So 0. Oh, I forgot about this. Here. All right. Okay. 0, 1. This is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now we have this array with all of these quads. And let's see. So when we have a digit and we want to get the corresponding texture, we can just say digit quads and index by digit, and that's it. Right. We have everything. Now positions, we'll find something for them. For now, they're all 0. I guess that's fine. And we want some code to draw. Drawing needs to be a bit simpler. I don't want to touch this material. Let's just make a new material for them. Simple material and digit material. It's the same thing. Won't be different. Material, digit. Because if you remember last time or before, the render expects when you're drawing, you are not changing the materials anymore. you're not changing the properties, and it gets messy to use the same material for everything. So I think it's just better. Yeah, and in here we can do the same thing, digit mat for initialization, give it proper matrices. This should be it for initialization. Yeah, this we'll handle ourselves, something more than switching the texture and so on. Right, and that's really it to draw a texture. So now we have a digit. Let's get a quad. So digit quads, digits, right? Score G for game. Digit. So we have these, and model material, we'll need to move them, otherwise Q, perfect. Here digits, and in here. So now we'll only see one digit, but I think that's fine. If you have like 10 or 11, they will draw on top of each other. Positions need to be set. Okay, so position, read write. So what we're going to do, this set for now 0 0 what are we setting the pipes to? 2. Pipes 1. Okay, I guess. Let's do that. Should see at least one something. No? Oh, there we go. Because we are skipping. Okay, +5. So we're seeing only the first digit. Okay, that's cool. So let's do x offsets. Oh, x offsets. Sorry, 0. Excuse me. This one, yeah. Okay. So what we want to do is, first of all, this thing is, so we have 10 being the top, maybe 9 on the y-axis, so just near the top of the screen, and then we can start centered. Thing is, we need to shift by how big the number is first, and then first let's handle a single digit score. I don't want to copy all of this. Here we just say, well, it's a kind of an infinite loop, but if score is 0, and the digit we got is 0. So we kind of have 2 zeros in a row. That means we can break. We need to know how many digits there are first. So let's do that. Let's get a score copy here. And while the score copy is bigger than 0, and digit count is at least 1. So we'll have that. And then every time we just do like 10. We just want to know how many. And then the offset is whatever our starting offsets. So digit count minus 1, because if we have one digit, we don't want to offset anything. So digit count minus 1 into whatever the offset is. So I don't know, let's say 1 unit. Well, 1.1 maybe. Let's do just over. Yeah. So we count how many digits in the number. We take the score copy again. And this is how much we'll offset each time. Into, so let's do current offsets is 0. We'll reduce. So we'll start at the right side, we'll draw it, and then we go to the left. So we're actually reducing. Okay. Yeah. So here we'll do X offset. We'll draw it, and then X offset minus 1.1. I think. Yeah. We draw all of those. 0, okay, in the center. Oops. Something died. Signal arrived. Draw elements. Q. So it came in, this was 1. Digit will be 1 divided by 0, it's 0. Offsets. So when the offset goes in the negative, that's when we break. So please do that. Simpler. Because the least offset is 0. We only have one digit. And then we minus, and that goes to the negative. That's it. Okay. And in here, we do, the mesh never really changes. The texture does change. We bind and we draw. Take this. Score again. Okay. Oh, we're not incrementing this. So that's one thing. It shouldn't matter here, because with one digit, this will be 1. This will not even run. Okay, actually, because if this is 5, this will get us 2. We don't want that. So I want to say if score equals 0, then digit count equals 1. Right? It's kind of our base case. Score is 0, then this is 1. Then if it's not 0, then they will count it here. Okay, so if it's 1, we'll get 1. So okay, so it's, but then the failure was in drawing anyway. So render. Why are we dying? We bound, we draw. We do all of this. And okay. I think we're setting the attributes. All of this drawing code needs to be abstracted away when we improve the render, hopefully. Okay. It's fine. Oh, by the way, so this I want it to be like 5. It should be even 7. Should be above everything on the z-axis. Then set attributes, texture, and this thing, and this thing. Shaders, simple. Ambient tint, diffuse. All that magic. Model matrix. Okay. It's fine. Let's see. 0 above everything. Cool. 5, 10. Okay, now it didn't crash. Was this one, I think? Maybe. Too hard. This is too hard. I should remove the collider as well. Okay, 5, 10, 25. Okay, let's increase by, so I want 2 numbers that are the same. So just increase by 11. Just to make sure that doesn't break the render. It does. It does. It does. Why though? Why do you do that? I think we encountered this bug before. Because the render doesn't bind again or something. Because we switch elements. So the render is supposed to detect a material change. And then bind it if the material is not bound. But if you pass it the same material twice, it doesn't, it assumes there is no change to the attributes. But that's why we are binding here ourselves. So why is this an issue? Model matrix. Let's go to run 3D. Okay, so the mesh, it's not bound. Our mesh doesn't really change, doesn't matter. Material, as you can see, if it's not bound, it binds it, but we are doing this work ourselves. And then it sets the model matrix every time and draws. Cool. should be fine for us. No. Bling, draw score. The way all of this goes bye-bye. And I think we need to scale it a little bit. Scale dot, 111 is the normal. Needs maybe, let's see. Okay. Diffuse. This is the same for forever, so we can do it. Digit quads 0. Okay. Set this. Set attributes. Oh, is this an issue? No, sorry, this we already did. Texture, draw, just fine. Bind, we always do. To make sure the texture is switched, because this is what's happening. But if there is nothing that has changed, this we don't need. Okay, throw pipe. This is fine. Same texture, so we just throw them in different positions for the pipes. And then we switch this, we bind, then we draw. And here as well. Matrix. Sort. Bound mesh. Okay, now we kind of stop the mesh from changing. Let's see. Yeah, a bit too big. Oh, went away. What's happening here, people? Is it the mesh? All the meshes should be identical. Sure. Maybe this would be different. Yeah, could be. I'm not sure. We'll look into it. But now let's look at this guy disappearing completely. So at 11, digit count should be 2. Print line, digit counts. Digit count 1, yes. Digit count 2. Okay. This is fine. What else? What else we got? What else do we have? So if it's 2, then it's 2 1.1. Offsets to be consistent. X offsets. Let's see. So it should start at 0 and then be 1.1. Yeah. Why? The screen should be 20 wide. So what's happening here? Is it not? Oof. Completely disappears. Maybe 1.5 for the scale, and then 0.1. It doesn't make sense. Okay. Let's do this. Just confirm. 0 is in the middle. Yeah. Size a bit better now. Wow, it disappeared. Even so, it's not the position. The same position just went away. We forget to call the material. Okay. No, it's just here and it's draw the constant mesh. Drawing the background. Texture attribute bind. This. Honestly, it's straightforward, so I have no idea. Well, let's just hardcode this for now. The digits, scale, digit quads, just to make sure it's the same mesh in case this makes a difference. And then yeah, this might be it. Let's see. Yeah, we just switched the mesh. Not good. Okay. And put back the offset. Put it back to 1.1. X offset delta. So we don't forget it. Cool. Score is a bit better. Okay, 11, 22, nice. Nice. Need to move it a little bit more so the delta goes into, I don't like this, 32 to like 1.3 maybe. You go bye and 1.3. I think the score is okay. And seems to be keeping the same position. Let's see at 100, hopefully. It's not exactly centered, but the first number is always at the same position. But what we want to do is we want to actually move it by half the distance. So we want to center the whole number. So in this case, our offset is halved. Is it halved or divided by all the numbers? The number of digits. I think we just half the whole thing. Okay, so we have 0 there. Now 0 should shift a little bit. For now, we're only drawing one number. Offset delta. So if we have 3 digits, we don't want to offset by 3 digits. We actually only want to offset by 1.5. Right? This is kind of the, so I think we have it. We have the offset. Kinda. And yeah, the offset also, I think, has to be bigger than the individual letter. If the letter is 1.5, it's not enough to move by 1.3. So if we have 4 digits right now, what we're doing is the 4th digit goes from 0, it goes essentially to position 4 on the screen. We want it to only go to position 2. It's already half. And so whatever the starting offset is, it's just halved. We did that. So let's see. So this offset is halved. And then we move by the same increments. We jump 2 each time. It's just the starting is different. Yeah. Why didn't this work the last time? It's weird. Okay, one digit's the same. What's this? Wired. Okay, let's go by. So if we have 2 digits, 2 into 2 is 4, 1. So the offset is 1. So we draw this at 1, and then we minus 2. And the next digit draws at minus 1. Okay, so this x offsets Yeah, it's 1. For 2 digits, it's 1, and we can see them on top of each other. Okay. And then what's the X offset after we're done drawing? Oh, right. This check is wrong now. Check is so our exit condition is so instead of this, we can just say, well, if just do this. So if I is less than 1 or score is bigger than 0, then we do this, right? So we're looping. We can remove this. If the score is 0, which is our issue, right? We don't want to copy all this. If the score is 0, we want to loop once, which is this. The score is bigger than 0 is false, but then I will loop at least once and then exit. Otherwise, if the score is not 0, then it will just do its thing, I think. Yeah. Makes sense. I think so. Okay, we got a bunch of textures. Oof. And we go into an infinite loop. Why is that? Okay, go. Oh, bye. Smaller one. And or score is bigger than 0. Score copy. Right. Oh, nice. Yes. Now we're talking. Distance is too much between them, so 2 is too much, maybe 1.7. And this score copy thing is making too many bugs. So let's just shadow the thing. So score is equal to score. So we don't need score copy anymore. Go. But when we change it, let's do this. Maybe original score. Right. So when we want to reset this thing after the counter, we can just say, well, score is original score. And then we edit score again. So we just use the score variable. We don't do anything else. Right. So now, yeah. So the left number shifted a little bit, which is what we want to keep the entire number shifted, centered. Perfect. And I hope at around 100, same will happen. Well, let's increase by some bigger amounts. Blink. Okay. Score plus like 51 maybe. There we go. Nice. I like it. Maybe we can shrink it still a bit more, so the delta can be 0.6. Nice. Okay. I think good work today so far. Okay, so this is that. What we can do is now, well, you have lost. If not I'm going, if inputs dot get dot key clicked SDL dot key enter, it's called enter return or return 2. So we want to essentially restart the game. Oh, right. So how do we restart? Well, we don't have a restart. So what we maybe can do is re-init. Just call game.init again, maybe. Although this will load everything. I'll call game.start. Yeah, init is, we don't want to call this again. Load the textures, all of that. Quads. Start. So in start, we set all of this. We make the pipes. We essentially, because the only thing that moves are the pipes, right? So we want to reset the bird's position, and we restart the pipes. We do the same rand magic and then let the loop go again. That's it. So pipes starts playing lost, resets pipe positions, restart the game. So what do we want to do? First, score goes to 0, and then the states, game states. Why is this not inside the thing, inside the game itself? Playing, right? Because now the state is lost, so I wanted to play. And then we are not going to create any new pipes, so we want to do just like pipes. We'll do the rand stuff, and p just equals pipes I. So p is maybe a pointer to a pipe, and then plus equals 2. I plus 1, right? Okay, we don't append anything. So same thing, we randomize, we set these positions, we reset the scales. We don't really need to do that. No need, just position changes. Position read right, and same thing here. scale is already correct, and then pipe position, blah blah, scale is already correct. Pipe X spacing. Okay. So we reset the pipes and that's it. Okay. So let's get a score of 1, 2. Okay. Enter. The pipes are gone. Oof. Mr. Pipe. No. Well, why did that happen? Same code. It's relative. Relative to start. What about the logic thing? We want to reset the pipe position, sorry, the bird position as well. That's actually something we need to do. Let's look at init. There should be enough. Pipe state. Okay. So starting position, the pipe. I'm not sure. Okay, you lost enter. All these are fine. Does it assume that there's like the position? Oh, it's position add. And this works because the starting position is 0 for a pipe. So when we get a pipe, we can just honestly, don't we just set? Now we have set, right? Set x, y, z. Well, okay. So we do that, and then this is set. This is set. Okay. Same thing goes here. Equals. There we go. Okay, let's see. With this, I guess we can end it for today. 1, 2, 3. Beautiful. Oof. So the bird velocity needs to be reset as well. So the bird state, birdie, Mr. Flappy, velocity is 0. New vec. There you go. And I don't think we have anything else. Mhm. Nice. Are they too wide? Maybe reduce width a bit. Okay. So position and speed are reset. Even, yeah, I'm jumping really hard. Well, so this is really annoying me, so I'll just put the game state here inside the game structs. Game. Where's the game struct? Oh, why is this down? Okay. Yeah, it's okay. All right. Just confirm. Oh yeah. So here, g.gamestate. So lost, press, enter to restart. Maybe something like this. And this this cursor position is really not working. We're positioning it at half, and then minusing the text size should be way back. Well, let's do this. Yeah, you know, okay. I'll take it. There we go. Nice. Lost. Okay. To do, I mean, this might not be important, this collider thing. Lose if bird goes outside screen. That's something we want to do. And then to do sounds, if we have sound library ready by then. And I hope so. I'll do. Right, so I think this is it. Today is day what? Oh, we're not doing the nMage one. That's fine. So we'll say score, show score with textures. Fix use size 1 quads, right? What else do we do? Game restart, right? So this is great. If you guys have any questions, please message me on Twitter or in the comments, but keep in mind what I said in the last video, which is that comments on YouTube seem to be disappearing sometimes. So it's safer to just hit me up on Twitter or something, right? See you everyone. Have a good day.